Hello, my name is Chris Chapman. I'm a mathematics professor at Tyler Junior College in Tyler, Texas, also an adjunct mathematics lecturer at the University of Texas in Tyler. And I'm making this video because I have a passion for logic puzzles. You might have seen some of the other videos I've posted on YouTube solving some puzzles just for fun and kind of getting into what I think when I solve some of these. This puzzle is called a double Choco puzzle or double Choco puzzle. I'm not sure of the origin of the word and hence how to pronounce it, but it's one of the puzzles that was on the United States Puzzle Championship that started on Saturday, December 31st, 2022, ran for a couple of weeks online. Maybe it was just 1 week, but regardless, it's a competition that I like to participate in. I've actually been participating in it so long that the first time I participated in it, the way the puzzle was delivered was through fax. You had to find a business with a fax machine. They would fax it to you. You would work it out. You would fax it back. So I've actually been doing this for quite a while. I haven't done it every year, but I try to do it as often as I can. Now, I'm never in the top finishers for a couple of reasons. Number one, there's some of the puzzles that I just can't solve. I try and I try to do the hard ones. Some of the hard ones I can do, some of the hard ones I can't. And the other reason is because some people just work faster at them than I do. I do this recreationally. I guess if you had to classify me as an amateur or professional, I'm an amateur, but I love doing them. I never get in the top so many places to be on the team that advances to the World Puzzle Championship. But I love teaching and I love showing people the thought process behind solving various puzzles. So what I'm going to do today is go over this double Choco puzzle, however it's pronounced. It's a puzzle that I'd never seen before. In this competition, you're allowed to review the instructions and samples of puzzles. So I kind of got a feel for it before we did them. And being a 5-point puzzle, it's one of the easiest ones because they range from 5 to 35 points. Um, but the goal of the puzzle is you're given a square with some cut into smaller squares, where some of the squares are unshaded and some of them are shaded. I will be referring to them as white and gray, and there are also various numbers in the puzzle. And the goal is to partition the puzzle into regions so that each region has the same number of white and gray squares, and within a region, the white and gray squares form congruent shapes. You can rotate and reflect them. For example, this region here has a gray region of 3 and a similarly shaped white region of 3. If there's a number in a region, then that means, I meant to erase, if there's a number in a region, that means each of the different colors has that many squares in the region. For example, this 3, there's 2 of them in here, means that both the white and the gray each have 3 regions. Now, some regions end up not having numbers, and that's okay. So, how do you solve a puzzle like this? Well, the one in the actual competition was a much larger grid, which I currently have here in Paint 3D because I'll be able to mark it up a little bit. And I just want to kind of go through some of the thought processes of how to approach some types of puzzles. And it's usually based on looking for things that have limited, if not very few options. And when I say very few, I mean one option. So remember, we're trying to partition this grid into regions where each region contains a white shape and a gray shape that are congruent. And if there's a number in that region, then both the white and the gray shape must have that many squares inside of it. So how do you start something like this? Well, usually what you do is you go for smallest and largest values and see if you can deduce something. For example, there's quite a few ones scattered in here, and I know that a 1 belongs to a region that has 1 white square and 1 gray square. And in some of the ones, we don't have any choices. For example, this one here has to be part of a region that has 1 gray square and 1 white square. And the gray and the white regions have to be adjacent somewhere. The only white square that's adjacent to this 1 gray square is the one below it. So automatically we know that that's one of our regions. Similarly, this one here only has 1 white square adjacent to it, and so one above it. By contrast, this one has 2 different gray squares adjacent to it, the one above it or the one below it. So although it only has 2 choices, I don't know which one it is, so I'm not going to focus on it yet. The other one, this one, used to have 2 adjacent white squares to it, but the one on its right was just used in the second region that we found. and so it has to be attached to the one on its left. So right away, we've already got 3 of the regions. The only other one, as I mentioned, we can't deduce which gray square it's attached to yet, so we'll come back to that later. All right, so where else can we go? Well, on the other end, we can go to the largest values, and in this case, there's a 5 all the way up here. This 5 has to be part of a 5 white square region attached to a 5 gray square region. Right now, this 5, the only way it can be attached to more white squares is to escape out of the corner here. And so we know those 4 squares must be in the region with the 5. Now, where's the 5th one? I don't know. Either it's to its left or it's below it. Now, can we deduce which of those white squares it is? Well, if we went to the left, then we've just formed this U-shaped region with 5 white squares, meaning there would have to be an adjacent U-shaped region formed by 5 gray squares. However, the gray squares attached to it can't form a U-shaped region, which means the 5 white squares are not in the U-shaped region and therefore are in this tall L-shaped region, or in this case, 7-shaped region. So we know that the 5 has to be part of this. Now, it also has to be attached to a gray region of the same shape. As we already mentioned, the gray ones up here don't form that shape, plus they spill into the 2, and the only other place that it's attached to gray is down here. So we have to find an L shape that's attached down here. If we go across 4, now we have a decision to make. Does it go up or does it go down? Well, we don't currently know the answer to that yet. So what we're going to do is we're going to go ahead and start the region with the white cells and then attach it to this region. But we don't know whether it goes up or whether it goes down. The only other line I could put is over here, but then it's just kind of, well, maybe that line will be helpful. Okay, now where can we go? I'm looking at the 3 at the very top. I'm not sure if we can attach in any gray cells yet, because the 3 at the very top has to be part of this 3 white square region. And I see 2 gray square regions that it could attach to, the one over here or the one over here. So I'm not quite sure which one that is, but I do know that we're going to have this. All right. Let's see, where else can we go? We can stay up here if we want to and try to deduce some things. Let's go to a square that doesn't have a number in it, namely this isolated white square, which is another good hint in this puzzle. Find a single color square that's isolated. That isolated white square is not attached to any other white squares. Therefore, it's part of a region that has 1 white square and hence 1 gray square. Can it be this gray square below it? Well, no, because that has a 2. And so if we did this, that would break the number rule, meaning that there's supposed to be 2 gray squares and 2 white squares. Could it be the one over here? Well, at first glance, it looks like it could, but consider the gray square above it. What would that attach to? Well, it's isolated from other gray squares, so it would have to be in a region with 1 gray square and hence 1 white square, but all the white squares around it are accounted for. The 5 to the right is accounted for, but the white square to the left is already part of that 3 white square region. So we can't have that this red rectangle here. That means that the only gray square this white one can attach to is the one to the left of it. And hence we have that. All right. Is there anything else we can do on the top? Probably. Looking to see if there's any contradictions that lead to a forced conclusion. I'm not seeing one quite yet, so we may have to walk away from here and resume later. Hey, you remember that one that I said we don't know what it belongs to right here? Now we do. It doesn't belong to the gray square above it, so it must belong to the gray square below it. And then we have that region. All right. Let's look at another square that doesn't have a number in it, the one below here. Another strategy is to find unnumbered squares that are either trapped or have to travel a long way to connect to the other color. Whatever region the square with the red dot belongs to has to be adjacent to a similarly shaped white region. So it's going to have to escape all the way down here just to be able to touch some white regions. Now, that doesn't necessarily help us yet, but consider the two above it. This two above it has to be part of a 2 gray square and 2 white square region. The only gray square adjacent to this 2 is the one to the left of it, which means we now know for a fact that that 2 has to attach over there, which also means that this white square is going to be part of that region, but we don't know if it's going to attach above. I know it's not going to attach below, because that would isolate the 5 gray squares with the red line through them. It might attach to its right, but we know it's not going to attach below, so we can separate these 2 white squares. And that also tells us what to do with that 5 gray square region, because it must attach to this white square and it must form this 5 square L shape. And the only possible place it could form is right here. And therefore, we know that one of our regions looks like this. That still doesn't tell us which of these 2 options are possible to attach to this region over here, but I see an isolated gray square right here. That gray square is not attached to any gray squares around it, so it must belong to a region containing 1 gray square and hence 1 white square. The only white square adjacent to it is immediately to its left, which forces this 2 gray square region to attach to these 2 white squares. I'm looking at the 3 above here. Clearly, all 3 of these gray squares belong to this region, which means we need a congruent 3 white square region attached to it. But looking around it, there's so many options that it could be. It could be that, it could be that, it could be that, it could be this, it could be this, it could be this. There's just too many options for us to decide what to do with that 3 for now. I see another square that is going to be forced to do something, and it's this gray square right here on the bottom. At least I think it will. Well, I know what it's not going to do. It's not going to attach to the 4. In fact, let's go back and focus on that 4 for a second. That 4 has to stretch 1, 2, 3, 4 gray squares over. So it can't reach that 5th gray square below it, which means that 5th gray square is isolated from other gray squares and hence is part of a region with 1 white square, and that must be the one to the left of it. All right, going back to that 4 region up here, I see multiple places that could be attached to this 4 gray square region. There could be these 4 white squares, there could be these 4 white squares, and there could be these 4 white squares. So I'm not quite sure which one that attaches to yet. Oh, here's something that I probably could have jumped on at the beginning. This 4 on the left side of the grid. The only 4 white squares attached to it are this. So I need to attach it to a gray shape with 4 white squares that looks the same. And looking around it, the only such one is up here. So those 2 have to be together. I see where this was a 5-point puzzle now. There's so many places where you're forced into making certain moves. Speaking of which, over here we have a 2 white, 2 gray region. So we're good there. Let's attach this. All right. Oh, the 3 on the top, we can finish now because there's 3 going across and the only 3 gray cell region of the same shape is right here. And that's going to force a few things. Number 1, it's going to force the 2 to create this region. It's the only 2 white cell region that can attach to it. And it gives us an unnumbered 1, 1, 1 region. I'm going to go ahead and do red lines across the regions that we've completed so we can kind of see what we haven't done yet. All right, we've completed this one as well. And now I'm looking at this 3 region, and the only choice to attach it to a congruent gray region is the one below it. So now we've got this. And consider this gray cell right here, which is to escape to white cells must be attached to that. It has to attach to a congruent white cell region, and the only option is the two immediately below it. Now we can complete the 5-cell region up here. Because remember, we had to make a decision at the end of this to go up or down, but now we must go down. Looking to the right of that, I see two isolated squares that get together and make a correct region. Okay. I see an isolated gray square right here. And the only white square it can attach to is the one below it. It can't attach to the one to its right because that has a 4 in it. Okay. Let's see. Speaking of the 4 has to go down. Now, if it didn't go down further, it would have to go to the right twice, but there's no gray-celled region that's congruent to that, so it must go down. Now, could it go down and to the right? Well, again, there's no 4-cell gray region that corresponds to that, so it must go this direction, and the only 4 gray cell section that it attaches to is the one immediately below it. Hi, Sophie. Come on in. Just give me like 3 minutes to wrap up this video. Okay, so we practically got the puzzle done. I see an isolated white square right here. Looks supposed to be in red. And it can either attach to the one to the left of it or the one above it. If it attaches to the one to the left of it, then these two gray cells don't have a 2 white cell region to attach to. So we can't go to the left, which it means it must go up, which isolates or which creates this region. The gray cell here must attach to the gray cell below it. So we're looking for a 2 white cell region that attaches to it. That would be the one immediately below it. And I believe we are done because this 2-cell region attaches to this 2-cell region. And the only other place we don't have accounted for is here, but it works. All right, so it's a pretty interesting puzzle because I'd never seen a puzzle like it before. I hope I can find more versions of it that are perhaps more challenging. So for those of you professional puzzle makers out there who happen to be stumbling across this video, it would be awesome if you could point me to some more puzzles of this nature.